So we're on the second section of this topic. So we're looking at some vocabulary here. So a horizontal asymptote, also called a horizontal line. It's a horizontal line. It's just this place that a curve can't pass over, and it's usually just y equals some number. When it is not horizontal, it's called the vertical asymptote. We have some other asymptotes, but these are the major asymptotes that we cover when we're analyzing rational functions. So how do we figure out which one is which, right? So whenever the numerator and the denominator have the same power of x, let's make sure we got this, the same power of x, you could divide the coefficients to find the asymptote. Whenever the denominator has a higher power than that of x, the asymptote is y equals 0. So let's look at some examples here. So if I have y equals x plus 3 over x minus 4, I want to find my asymptote. So I'm going to look at the powers here, right? And my asymptote, those leading x terms, I'm looking at my leading x terms, and that asymptote is going to be 1. Another example for this one. Another example, let's say I have y equals 2x cubed minus 15 over x cubed plus 1500. Notice these numbers here don't matter, but those leading x terms, if I had other x terms, x squared right here, wouldn't matter. I just really need those biggest power x terms. If I simplify here, y equals 2 would be my horizontal asymptote. That's how it works. Now, if let's say I had something similar, let's say I had x plus 3 over x squared, right? Doesn't matter what the number is. What matters here is the exponents. If the one at the top is smaller, then my asymptote automatically is 0. Whenever the numerator has a higher power, divide them, and the asymptote actually just simply doesn't exist. It does not exist. When the asymptote, when the numerator has a higher power, there is no asymptote, actually. So a vertical asymptote is interesting. So we get it from when we have a function. Let's say we have some equation over another equation. So the numerator over the denominator. So my vertical asymptote comes about when I've simplified this function, and I would say simplified the function, right? And I set the denominator equal to 0. And I solve for x. And it's going to be x equals some number. It's going to be x equals some number. And it's a vertical vertical line. Now, the x-intercept is always where a function it's a point. Looks like this, x comma 0, where a function crosses the x-axis. Or an object. We typically call everything a function, and it's totally incorrect. So the y-intercept is the point 0, y, where a function or object crosses the y-axis. And that's all she wrote. We will move forward a little bit and just graph our first function here. We're going to look at this and we're going to factor. We have x over x plus 5 times x minus 1. And obviously, we actually have two factors in the bottom. None of them cancel out, so I'm going to set them equal to 0. And x minus 1 equals 0. And here I get x equals negative 5, so I have a vertical asymptote here, and x equals 1. So I have a vertical asymptote here. So vertical asymptotes here, I have x equals negative 5, and x equals 1. All right. So I'm going to go ahead and draw those on my graph. So at 1, I have this vertical asymptote. All right. At negative 5, have another vertical asymptote. And so the question is, what might this graph look like? I have no idea, but we can still find some other information at this point. I do want to do horizontal asymptotes, and the reason I want to do that is to say that I want to look at these leading x terms right here, my leading x terms in the original, my horizontal asymptote here. Remember I said if the exponent in the top is smaller than the one in the bottom, then my horizontal asymptote here is y equals 0. So we're going to write that down. So that means I have, and I'm going to do it in pink. I'm going to do it in pink here. I have a horizontal asymptote right here. Okay? And I'm just going to go through a label. And I just want to do this one problem. So x equals negative 5, x equals 1, y equals 0. So what does this look like? Well, if I go to Desmos and I graph it, I can get a general idea. And I just want to get like the general way it might look. So I have, and I'm doing this on a different device, so I hope that you are doing this as well. And actually, you know what? I will just bring it up. So Desmos graphing calculator. And I'm going through these actions because you need to get a general idea of how long something like this takes. So I have x over x squared. Oh, I'm always messed that up. And I have to be careful. So that means you need to take care with the way that you are doing and putting information here. And I'm going to square that. And we have y equals, right? I'm going to go back on that. And wow, what an interesting graph here. I'm curious. This looked nothing like what I expected. I want to go ahead and throw those asymptotes in there. X equals 1. And I'm going to go check because my calculations, at 1 we have a 5. And that shouldn't be right. So what I'm going to do is I'm going to put it in where it's factored. So let's undo right there. So x over x minus 1, nope, x minus 5, nope, plus 5 times x minus 1. Yeah, I knew something was wrong with this graph. I'm not sure what I did wrong there. I knew something was wrong with this graph. So this is actually how it's supposed to look. I'm trying to make it smaller. I'm gonna screenshot that and just drop it into. That's why you always that's why it's good to know math, guys. Because that could have went horribly wrong. And if I didn't recognize some of the graphical characteristics, I would have made like a really big mistake, and it would not only would it have just not like been good for me, it would have not been good for you. So let's draw my curve here, and I'm going to do it in black. And it looks like my first one looks something like this. Second one, I'm glad I'm spending a lot of time with this particular topic because it's so important when you're moving beyond this subject here. So let's look at in behavior. So where do I look for in behavior? For in behavior, we're going to look here on this side and here on this side. All right, so as I approach x goes to negative infinity, what's happening to my y values? They are going towards 0. As x approaches positive infinity, what's happening to my y values? They are going towards 0 as well. If you look, it's getting closer and closer to 0. Now, x-intercept, so where does it cross the x-axis? Here. And that looks like, to be precise, looks like it's doing it right close to 1. Actually, it's doing it right at 0. So I have 0, 0 there, and similarly 0, 0. And if I plug it in, I get 0 over 0 plus 5 over 0 minus 1, and it's just 0. So that's correct. So I'm going to leave it at that, and we'll pick back up next class with the rest of graphing. Have a good day.